All right, we started these notes yesterday about solving these logarithms, but up until today, you had one logarithm like this. So you had one logarithm equals a number, but here you have two logarithms. But we can make it one logarithm. We did this by condensing them into one. So these two are being added together, right? So if I condense these, it would become log of x times x plus 3 equals 1, or log of x squared plus 3x equals 1. Now the rules from before, they all are the same, like everything applies. So I've condensed it, I've isolated my log, so now I'm going to rewrite it as an exponential. So the base here, this is a common log, so the base here is 10. So it'd be 10 to the first equals x squared plus 3x. Now this is a quadratic, so how do we know how to solve quadratics? You could factor, you could use quadratic equation, you could there's lots of different ways that you can solve this, but most likely you're going to factor. You can always use a quadratic equation, but you're going to remember that you're going to have to check your answer. So I'm going to factor this. So I'm going to subtract 10 from both sides, because either way, if you factor or use quadratic equation, you're going to have it set equal to 0. So I have 0 equals x squared plus 3x minus 10. So to factor this, what two numbers multiply to negative 10 and add to 3? Those are x plus 5 and x minus 2. So my two solutions here would be negative 5 and 2. But I need to check, right? I need to check from my original equation here. So I need to check to make sure, okay, when I plug in negative 5, my arguments can't be negative. So if I plug in negative 5, right, I would get the log of negative 5 plus the log of negative 5 plus 3. Now both of these end up having negative arguments. So this is not an answer. So negative 5, not an answer. So, and it doesn't have to happen to both. It could just happen to one. Okay, I could also plug in 2. So I would have the log, because I might have no solutions, that's possible. The log of 2, that one works, plus the log of 2 plus 3. That one's also, the argument's also positive. So 2 is a solution, but negative 5 is the extraneous solution. And they might both work. None of them would work. One could work. So number 6, I'm going to condense this. So I've got a negative log base 6 of x minus 5. So that x minus 5 is going to go in my denominator. So I get the log base 6 of x over x minus 5 equals 2. I've condensed into one logarithm. I've isolated my log. Now I'm going to rewrite it as an exponential. So this becomes 6 squared equals x over x minus 5, or 6 squared is 36. So 36 equals x over x minus 5. To solve this, I don't like this fraction here, so I'm going to multiply both sides by x minus 5. On the right-hand side, what happens here is that's going to cancel out my denominator. So I would get, on the left-hand side, I'm going to distribute this, get 36x minus, okay, 36 times 5 is 180. So 36x minus 180 equals x. I'm just solving for x. So I'm going to get all my x's on one side, everything else on the other. This isn't a quadratic, so there's no factoring or anything, because it's to the first power. This is a linear equation. So I'm going to add 180 to both sides. I get 36x equals x plus 180. Get rid of one x here. So 35x equals 180. So if I divide by 35, okay, I get x is equal to 180 over 35. Now, you should be able to see that this is definitely simplifiable, right? And your calculator will do that for you. If you did 180 divided by 35, it will give you a simplified fraction, but this would give you 36 over 7. And when I plug this back in to my original, okay, if I plug it back in here for this x, that's positive because it'd be log base 6 of 36 over 7. But if I plug it in over here, 36 over 7 minus 5, it is it is still positive. That's fine. As long as it's positive. It's barely positive, right? It's 1/7, but it's still positive. So this is a solution. Here we're going to, there's two logs here. So this is interesting. Log base 8 of something equals, I'm going to rewrite it like this. So log base 8 of something equals log base 8 of something. Well, it should make sense, and I won't write that there. Maybe I'll write a heart. Okay, so it should make sense here that these two somethings must be the same, right? Log base 8 of something equals log base 8 of the same thing. They're going to have to be the same thing. They can't be two different things. So in this case, I can just get rid of these log base 8s, and I can set x plus 6 equal to 4x minus 9 and solve. So I'm going to subtract x. 6 equals 3x minus 9. Add 9. So 15 equals 3x. Divide by 3, and so 5 is x. And I want to check, okay, when I plug this back in, is 5 plus 6 positive? Yeah, it's 11. And here, 4 times 5 is 20, minus 9 is 11, also positive. So that's my answer. Okay. Number 8, you could do this a couple of ways, okay? You can condense these into one natural log, or it looks really similar to number 7, okay? Because I have two logs, but I could add the natural log of 5x minus 10 to both sides, and I would get the natural log of 4 plus 5x equals the natural log of 5x minus 10. And now this looks just like the one above it. So the natural log of something equals the natural log of, it must be the same thing. So I can go ahead and get rid of these natural logs. And I can say 4 plus 5x equals 5x minus 10. And I solve. So I'm going to get all the x's on one side. So I subtract 5x, and I end up with 4 equals negative 10. Well, that's not true. That's not a true statement. 4 doesn't equal negative 10. So because that's a not true statement, there's no solutions here. If it was, let's say, 4 equals 4, that would mean that there was an infinite number of solutions. So all real numbers, that would work. But that would mean that they were the same natural log of this graph of this exact same line. But here, these are the graph of two different lines that actually never intersect. That's what you're actually trying to find. So here, the natural log never intersect. It might look something like this. And it kind of looks like they do intersect, but maybe like that. And they would never intersect. Number 9 here. Now I can't end up getting these two natural logs to cancel out. You can't do that. I have 3 here, so I don't have 1 equaling 1. But I could get 1 equaling 1, couldn't I? Because I could condense these into 1. I could make this one The left-hand side's already 1. So this rule here, right, this 2, if you remember from your properties, it's going to become an exponent over here. So this, on the left-hand side, this is the natural log of x squared equals. Now if I combine, if I condense the right-hand side, that would become the natural log of 2x minus 3 times x minus 2. And now I have a natural log of something equals the natural log of something. So I can get rid of my natural logs here. So I have x squared equals, now on the right-hand side, I'm gonna multiply this out. So I've got 2x squared minus 4x minus 3x plus 6. I have a quadratic, so I'm going to factor. That's the way that I like to do it. If you like to do complete the square, complete the square. If you like to do quadratic equation is fine. But I'm going to subtract x squared from both sides. So I have 0 equals x squared. Now negative 4x minus 3x becomes negative 7x plus 6. So to factor this, the two numbers that multiply to 6 but add to negative 7 are negative 6 and negative 1. So my two solutions here are x equals 6 and 1. So I'm going to start by plugging in my 6 up here. So this, the natural log of this would be just the natural log of 6, so that's positive. Okay, so in my second one, 2 times 6 is 12, minus 3 is 9. That works. And 6 minus 2 is 4. Awesome. Good. That one works. All right, so now I'm going to try 1. So now I've got the natural log of 1. Yeah, that works. Okay, 2 times 1 is 2. Minus 3 is negative 1. Nope. 1 is an extraneous solution. So x equals 6 does work, though. So go ahead and work on your homework. Make sure that you check for your extraneous solutions. You're going to want to do that.